Hi, I'm Hunter Reinke.
I'm Michael Miller.
I'm Bryce Burke.
And I'm Greg Jowett, and we are from the Blizzard Baja Racing Enterprise. Blizzard Baja Racing is a collegiate design team that designs, manufactures, and tests a single-seater four-wheel drive vehicle. We take the car to regional and national competitions, and in the 2023 competition season, we placed 8th out of 100 teams in Oshkosh, Wisconsin. To optimize our current design, we are redesigning our CVTs to be electrically actuated and combining our gearbox, transfer case, and rear differential into a single compact case. These projects were sponsored by the Blizzard Baja Racing Enterprise with assistance from American Axle.
Our design objective was to create an optimized four-wheel drive system containing a gearbox, transfer case, and eCVT capable of running a four-wheel drive Baja vehicle. Our targets were to reduce the weight of the car, improve efficiency, and have condensed packaging compared to that of our previous four-wheel drive system. This sketch represents a full layout of our optimized drivetrain.
The gearbox contains a gear train made up of the spur gears shown on the right. The input shaft is powered by the eCVT, and then the gears transmit the power to the transfer case, which sends power to the front differential. Then the differential transfers the power and sends it to each of the front wheels. The gearbox also powers the rear CV axles, which sends power to the rear wheels. The gearbox itself creates an 8.2-to-1 gear reduction, which is delivered to the rear wheels as well as inputted into a 2-to-1 transfer case. The front differential has a 1-to-2 gear ratio, which results in the same RPM being delivered to both the front and rear tires. This gear ratio was calculated with a top speed of 40 miles per hour in mind, with the Kohler CH440 motor. The purchase components were bevel gears, aluminum stock, bearings, snap rings, O-rings, and hardware such as bolts. The manufactured components were spur gears, the input shaft, the transfer case, the gearbox cover, shafts, and mounting tabs.
This gearbox will improve the overall efficiency of our design through its simplistic and efficient design. The spur gears and bevel gears will result in a high efficiency while maintaining a strong and rigid design confirmed by Kissoft used by American Axle. The aluminum gearbox allows us to house our gears in a lightweight casing while maintaining a factor of safety of 3.7 that will ensure longevity of the entire design. American Axle ran a Kissoft analysis to confirm our FEA results, and they found that our gears were slightly overbuilt, having a factor of safety of 2 to 3. The pictured mesh shows the results of the highest force mesh, resulting in a gear factor of safety of 1.5. In conclusion, we reduced the overall weight of the previous four-wheel drive design, we created a high-efficiency design, and our gears were slightly overbuilt. We would recommend for future members to do a transfer case optimization, as well as optimize the gears in the gearbox to reduce the overall weight of the design.
Looking at the figure on the left, it shows the assembly setup for the eCVT. The linear actuator motor is attached to a gearbox that has a pinion welded to the end of its output shaft that meshes with a rack that is mounted in parallel to the engine. At the end of the rack, there is a linkage.
The linkage is bolted to a 1-to-1 lever arm, allowing the lever arm to be fixed in the center and swing along an arc on both sides. The fulcrum of the lever is supported by a bracket that is mounted to the faceplate of the engine. The other end of the lever is connected to a custom throwout bearing that shifts the movable sheave. On the right side of the screen, you can see a completed CAD model. The top two images show the eCVT at its highest and lowest gear ratios.
The image on the bottom is the linear actuator assembly, which is made up of a motor, gearbox, rack, and pinion. Out of all the assembled parts, manufactured parts include the throwout sheave, the bracket, the fork, the bracket arm, and the movable sheave. Purchased parts would include the brushless DC motor, motor controller, planetary gearbox, pinion, gear rack, and all necessary hardware.
This slide highlights the four main components of the eCVT that will be manufactured in-house. From left to right, they are the bracket that mounts to the faceplate of the engine, the bracket arm that acts as the fulcrum for the lever arm itself, and a custom throwout bearing. All of these parts will be manufactured out of 6061 aluminum alloy.
Looking at the safety factors, the bracket has the lowest at just under 1.5. Fortunately, if this proves to be an issue in the future, there is enough clearance in the design to thicken the bracket without changing anything except hardware. When this project was first conceptualized, we planned on purchasing an off-the-shelf linear actuator and an off-the-shelf throwout bearing. However, we realized that because this is such a niche design, both of these components would need to be custom designed for this project. Knowing this, we recommend that future teams conduct a failure mode and effects analysis early on to help predict potential project delays.
Further recommendations for this project would be doing lifespan testing on the bearings to determine maintenance intervals, along with coding the microcontroller to actuate the movement. This will be an iterative process to determine the most effective actuation curve for different race conditions.
Thank you again to the Blizzard Baja Racing Enterprise and American Axle for making these projects possible.